So in the previous recording, we have already discussed how to calculate the coupon rate and how to do the calculation for current yield. Now I'm going to show you how we're going to do the calculation for yield to maturity using the trial and error method. So for that, okay, wait for a moment. So for that, we're going to write down the bond valuation formula, which is your PMT multiplied by, sorry, 1 plus R. So your R will be, or I'll just leave it R right now. Minus N, I'm going to write the whole formula so you don't get confused. Plus we have base value 1 plus R to the power N. Now we're going to plug in the values. So bond value, we have this value 950 rupees. This is the price at which the bond is selling. So this is the bond value. This is the price of the bond. So you can have 950 over here. Coupon payment. The coupon payment is also given to you in the question. So we have 80 multiplied by, now we do not know what the R is. The R is missing over here. So I can replace the R by YTM since that is what we're trying to figure out, and it is same as the market interest rate. And we have YTM over here. Even if you just use R, then even then it's fine. The maturity is 6. The face value is 1000. 1 plus YTM power 6. Now you can see that what were you doing before and what are you doing right now. Before you were given the rate and you were supposed to calculate the bond value. Now you're given the bond value and you're supposed to find out the rate, which is called your yield to maturity. So how are you going to solve this? You cannot keep YTM on this side and shift everything else on the other side like we used to do. You will have to use the trial and error approach. The trial and error approach means that you're going to plug in different rates, assume different rates, and see where is your answer coming 950. So you might use a rate of, let's say, 9%. And you'll check, is my answer coming 950 or not? Then you will try maybe a rate of 10% and see, is my answer coming 950 or not? So basically you will plug in this rate, 9% here, 9% here, 9% here, in all three places, and you will keep on doing this until your answer is very close to 950. Now I already know what the YTM is, okay? So the rate that will give you the correct answer is 9.119%. But you can see that you would have to try so many multiple times before you get the correct answer, which is a very long and tedious process if you're doing it manually. If you use an Excel spreadsheet or a financial calculator, then the calculation can be done really quickly and you will get the exact answer. So now that we know what the exact answer is, let's see what does this mean. So I'm going to plug in this interest rate over here. So 1 minus 1 plus, now this is 9.119% minus 6, 9.119%, 1000, 1 plus 9.119% power 6. Now, if you do this calculation, you will see that your answer is coming very close to 950. So if you try this, your answer might be coming 949 point something or 951 point something. All of these answers are considered to be close enough. Okay, sorry about that. So basically, this is what you're supposed to do in the trial and error. It is a very long and tedious approach. How are you going to figure out by plugging in different rates at what is going to be the exact rate? So instead of this, we do have another methodology, which is your approximation technique. So this is your approximation formula. You can use this to get an approximate YTM. Now, The word approximate is used over here, so you will not get the exact answer, but yes, you will get a close enough answer if you use this formula. The C over here represents the coupon payment. The FV stands for face value. The PV is the price of the bond. It is the present value. The T represents the maturity. So basically T over here means N for you. Again, FV and PV we have already discussed. So let's use this formula in the previous example now. So we're going to use this formula. The coupon payment was 80. The face value was 1000 minus 950 was the price. N was 6. And then divided by face value, again we have 1000, then plus 950, and then divided by 2. So if you solve this, you get 80 plus 8.333, and this keeps on going. And then you have 975 over here. And if you solve this, you get 9.06%. So multiply your answer by 100 to convert it into a percentage. Now you can see the correct answer was 9.119%. And this approximation technique has given you an answer of 9.06%. So it's not the exact answer, but yes, it is close enough that this approximation methodology can be used. Moving ahead. Now we're coming to another concept, which is your yield to call concept. Yes, I will discard these. Okay, so the yield to call is different from your yield to maturity. Yield to maturity tells you, let's go back to yield to maturity. Yield to maturity tells you the total return that the investor will get if he holds the bond till maturity, whereas yield to call is going to tell you the return that the investor will get if the bond gets called. Now, if you're not sure about what is a callable bond, I would recommend that you go back to the previous unit's video in order to clarify that. We've already discussed this. A callable bond is a bond that can be called by the issuing company at any particular time if there is no deferred call period. Now, basically, your corporation, if they're calling back the bond before its maturity, that means that the bond is no longer going to go till maturity. And if it's no longer going till maturity, then the investor is not going to get the return that the yield to maturity is telling you. They are instead going to get the return till the call date. So over here, you're going to calculate return till the bond gets called. So that will be the return for the investor in that case if the bond is going to be called by the corporation. And we already discussed also that when is corporation most likely going to call back the bond. I hope you can remember that, and if you don't remember, then do go back and see those videos. So now we are saying that this bond is callable after 3 years at 5% premium. So after 3 years, the total maturity of the bond was 6 years. The N was 6. So that means, let me make a timeline for this. 0, 1, 2, 3, 4, 5, 6. Now this basically means that if the bond had gone till maturity, the investor would have gotten these cash flows. So the coupon rate was 8%, 80, so 80 every year. Plus, once a bond would have been called back, they would have gotten the face value of 1000 back at the end of the 6th year. But now things are different. Let me just use another color. Now it is being called after 3 years. So it's going to get called at this point. So the bond is going to end at this point. And if the bond is going to end at this point, the future interest payments will not be paid to the investor. This 1000 will actually be returned back to the investor over here. and the bond is going to cease to exist. It was a loan, right? A bond is a type of loan. So if the loan principal amount has been returned at year 3, the bond will cease to exist and the investor will not get the future interest payments. Now it is going to be called at a 5% premium because the company is ending the bond before the stated maturity. They will have to pay a premium on it, which is an extra amount. So they're going to pay a 5% premium on it. So 1,000 multiplied by 5%, that means they're going to pay a premium of 50 on the bond. So instead of giving just 1,000 back to the investor, they are going to give 1,050 back to the investor. So now the cash flows for such a person are these. For such an investor are going to be these. So he will get the first year coupon payment, the second year coupon payment, the third year coupon payment, and at the third year he will get back the bond value plus the call premium. Now you want to calculate what is the return of such investor, which is your yield to call. So for that you can still use the same approximation formula. So your coupon payment is 80 plus your future value. Now the face value over here is not going to be 1000 because that is not the value that they're getting at maturity. At maturity has changed to year 3 now, and at year 3 they're going to get 1050 instead of 1000. So your face value is going to be 1050 now. Okay, the price is going to be the same, so that is 950. The N means maturity, so it's going to get called in 3 years. So the maturity is going to be 3 now. Plus 950 and divided by 2. So if you solve this, this will be 80 plus 33.33 and divided by 1000. So this will give you 13.33%. So if the bond completes its maturity, it will give the investor a return of 9.12%. And if the bond ends before maturity, the investor will get a return of 13.33%. So the investor will be compensated for the bond that is ending before its time. But in order to understand this better, that why would a corporation that would still do that, you should go back and see the recording on callable bonds, the previous recording, so you'll understand that your investor, even though he will get a higher return, he will have to invest this 1050 now at a lower interest rate, so that there is an opportunity cost attached with this higher return actually. And with this, our topic ends.